So let's have a look at integration. So use integration to work out the area of the image of the wave. That is the area bound by f and g and the x-axis when x is between 0 and 2. So basically what we are looking for this area here, between the two waves. Okay, and then they are reminding us again what is function g and function f. So we know that one is quadratic, the other one is cubic function. So how do we find the area between the two curves? So area between curves. Well, curves, straight line, x-axis, anything. So, oh, that should be red. So we are integrating, right? Because that's how we find the area within given interval. And first step is to consider the value of the function that have high values of y. And from that, we take away the value of the function that have low value of y. Now, what do we mean by that? Let me explain. Let me remove that. So let's see. Now I pick the value of x here. So for this value of x, let's say that's 1.6. This function g, that's where it is. So value of y will be, I don't know, let's say 1. And then for the same value of x, function f will have, let's say, value of y being 1.7. Yeah, so that's what I mean by high and y and low values of y. So in our case here, that means our interval is within the boundaries. So 2 higher interval, 0 lower interval. The y high is the fx function. So minus 1 over 4x to the power of 3 plus x to the power of 2, and that take away the second function. Now, here I would say to put function inside the brackets, and I tell you why I'm saying it. Because from this function, fx, we take away this function. Now, what will happen, because I have a minus, the signs here will change, all of them. So that means what we are dealing with, let's remove that bracket, plus x to the power of 2. The minus will make it here plus 6x to the power of 2 here. That will be minus 25x, and here will be plus 24. And now I have a function that I can integrate. Well, actually, first, let's simplify it out. So I have minus 1 for x to the power of 3. Let's not forget we are integrating. Then I have here 1 and 6 together. I have 7, isn't it? Then I have minus 25 and plus 24. So how do we integrate? Well, we integrate each element, isn't it? To each element, we're going to apply formula. And those elements are simple enough. They all reflect our x to the power of n. And that's the very first formula in our table when it comes to integration. That's the one here. X power plus 1 divided by power plus 1. So x n plus 1 divided by n plus 1. So let's apply that to each of the elements. What happened with the number? The same as it is with derivative. Carried over, crosses over. Then we have x. The power here will be 3, so it will be 3 plus 1 over 3 plus 1. So 3 plus 1 is 4, 3 plus 1 is 4. Plus 7 again crosses over. X power is 2, so it will be 2 plus 1, 3, and 2 plus 1, 3. So it will be 3 and 3. Minus 25 crosses over, and again x. The power here is what? 1. So 1 plus 1, that will be 2. 1 plus 1, that will be 2. Plus 24. And what happened here? The number that doesn't have x gets x, isn't it? That's the idea, because remember, when we integrate, we reverse the process of differentiation. And normally, if that was the function and I was differentiating that function, didn't mean to press that, the derivative of that will be only 24, isn't it? So that's the reason why we are adding. Okay, so now that we have those values, I'm just saying, do we work our numbers a little bit? Well, we can or not. Doesn't really matter. There's not going to be much of simplification. What do we do in the next stage? We find the value. So we take all that function and we replace each x with 2 and then minus. And then again, we take that function and we replace each x with 0. So let's do that. So minus 1 over 4 multiply instead of x 2 to the power of 4 over 4 plus 7 multiply instead of x 2 to the power of 3 over 3 minus 25 multiply fraction instead of x 2 to the power of 2 over 2 plus 24 multiplied by 2. So from that, we take away, and again, the same function, 1 over 4 multiply 0 to the power of, not 2, 4, that should be 4 over 4 plus 7 multiplied by 0 to the power of 3 over 3 minus 25 multiply 0 to the power of 2 plus 24 multiplied by 0. Now, what happens here, that here, because there is multiplication by 0, multiplication, all of that will be 0. So really what I'm putting in my calculator is this part here, because that will give me a number. I'm pressing equal and my number is 47 over 3. So that is the area that they were looking for here. So let's just restate again. So how does that happen? Area between the curve. First, we consider which function have the higher values of y, which one have the lower for the same value of x. So that's what we subtract first. Like I'm saying, put them in bracket minus so that you don't get confused. We just simplified it. And then we're doing what? At this stage, we are saying we're going to integrate. So we are applying formula to each element. So we've done that here. And now once it's done that, we are saying now that we've integrated, we are looking for a number. So we take this function, we replace each x with the higher interval, that's done here, minus, and again the same function replacing x with the lower interval. And then everything in calculator, press 0, and we have our answer.